The fire test was carried out on the 27th of January 1994 in the fire laboratory of the Knauf company in Iphofen, Germany. Aim of the test: a comparison of the steel panels generally used overseas for access floors with the European F30 solution. The main argument put forward by the manufacturers of steel panels is that they're non-combustible, but the fire test demonstrates the dangerousness of steel panels in case of fire. For the purposes of the test, one PVC-coated Goldbach anhydrite panel L600A was used, and one uncoated panel of the same type. This type of panel is regarded as the classical representative of the Goldbach products for access floors. It's a high-density, fiber-reinforced calcium sulphate panel. All Goldbach panels are equipped with edge strips to facilitate sealing. These Goldbach L600A panels were compared in the fire test with steel panels of an unnamed manufacturer, using one panel with an HPL coating and one without a coating. The steel panel with an HPL coating is regarded as the classical access floor panel overseas. The fire test was carried out in a test stand for ceilings and walls. Dimensions of the furnace: height 1.25 meters, width 1.25 meters, depth 1.5 meters. The panels to be tested are placed as a cover on the open furnace, and 3 heat sensors are attached to each panel to register the surface temperature during the fire test. The data are stored and analyzed in a computer. The heat in the furnace is generated by an oil burner and increased to DIN 4102 ETK. The temperature in the furnace is measured by thermocouple elements, and these data are also fed into the computer. A glance into the open furnace clearly reveals the 2 steel panels on the right and the 2 Goldbach anhydrite panels on the left. Before the fire test starts, the furnace is closed, and the test on the basis of F30, that is fire resistance for 30 minutes, can begin. After 3 minutes, the static overpressure in the furnace amounts to 10 Pascal, and this was kept constant throughout the test. Measurements were taken halfway along the 2 side walls at a distance of 100 millimeters to the ceiling heated by the flames. After 3 minutes, a sharp report and crackling sounds were heard from the steel panel with HPL coating. The slight vapor rising between the Goldbach panels is caused by a heat-induced swelling of the edge strip. After 5 minutes, the increase in the surface temperature of the Goldbach panels amounted to 18 Kelvin. The surface temperature of the steel panels, on the other hand, amounted to 145 Kelvin. After 9 minutes, the HPL coating of the steel panels caught fire. The surface temperature was registered as 280 Kelvin. After 10 minutes, the surface temperature of the Goldbach panels was 23 Kelvin. But the surface temperature of the steel panels was 295 Kelvin. After 15 minutes, the surface temperature of the Goldbach panels measured 47 Kelvin, compared with 335 Kelvin surface temperature of the steel panels. After 20 minutes, the surface temperature of the steel panels had risen to 385 Kelvin, while the surface temperature of the Goldbach L600A was only 61.5 Kelvin. After 25 minutes, the surface temperature of the steel panels amounted to 410 Kelvin. That of the Goldbach panels, 61 Kelvin. After 30 minutes, the surface temperature of the steel panels was 420 Kelvin, compared with only 62 Kelvin for the Goldbach panels. The fire test was concluded after 32 minutes. This graph illustrates once more the differences in the surface temperatures between the steel panels and the Goldbach panel L600A. The hazard represented by the steel panels after only 5 minutes of the fire test is clearly revealed.